Hey guys, my name is John Grimsmo, and for those who don't know me, I make awesome things. Now today I've got a unique opportunity for somebody out there. I'm selling my old CNC milling machine. Now let me answer 3 questions right off the bat that you're probably going to ask. Number 1, how much? $3,500. Let me quantify that in the rest of the video and explain the price. Second question, why am I selling? Because recently, a few months ago, I got a new milling machine. This is my Tormac PCNC 1100 versus the old mini mill. Quite a bit different. And the third thing you have to know right off the bat is I will not ship this, I will not deliver this. It has to be picked up here in Hamilton, Ontario. Other than that, let's move forward. Let me show you what's going on here. So what you're looking at is a Grizzly G8689 mini mill, also commonly called a Sieg X2 or Grizzly X2. These were very popular machines. They still are. And there's a lot of information out there on the internet, on the CNC forums, on people's websites about how to upgrade these and tweak them up and make them pretty awesome. And that's what I've been doing. I've had this for about 3 years, and it's been converted to CNC for the past 2 years. I converted myself. I made all the brackets, all the wiring, did all that myself. And it's been a pretty stout machine. Okay, that's better. I had to close the garage door because the extra light wasn't worth the extra background noise. Anyway, being a hobby class machine, there are always issues, variables, things that break and tweak and you have to mess with all the time. That's just the name of the game. And this has been a constant upgrade for me. Except, lucky for you, I've spent 3 years upgrading this bad boy and fixing all the crap that doesn't work right. And we're left with a pretty neat package. Let's get down to some details about the machine, about the conversion. I used stepper motors and ball screws to linearly drive everything. During the course of the upgrade to CNC, I've increased the table travel. It's got about 11 inches X, which is left to right. It's got about 4.25 inches in and out, that's the Y. And the Z is, I forget, it's around 10 or 12 inches. I never use the full Z axis. You only use like this much, depending on what you're machining. But yeah, 10 to 12 inches on Z. Originally, when you buy the machine, this is the spindle motor, and to drive the spindle, it uses plastic gears. 2 plastic gears that are intertwined. And they're made of the most terrible plastic ever because they break the first time you do any milling, really. I mean, you can't mill very aggressively with those gears. Inside here you can see I've made, using my CNC lathe, I've made these 2-stage pulleys on both the motor bracket, the motor and the spindle. I made this plate, made the spacers. It's a belt drive now. So the spindle drive is very good, and I've increased the RPM. So the high speed has up to 6,000 RPM, and the low speed has up to 3,000. So 6,000 is pretty good for such a small machine. Alright, so you're probably wondering what this big fancy orange thing is. This is a really cool aluminum bracket. There's the same one on the other side that I machined on this mill itself. And this whole setup is called a power drawbar setup. So basically there's a button here, which when you apply electricity and air pressure, which I do not have right now, the machine's not plugged in. But when you apply all that and you hit the button, this air cylinder is full of 100 psi of air, and it shoots down and hits this lever arm and actuates the bolt that goes through the spindle, which holds your tool. For example, here's a tool holder. I will be including a lot of these in the sales, so get to that in a minute. But basically you push the button, and then the collet here opens up and you can pop your tool inside. And then when you let go of the button, the tool is held in very well, very securely. Tool goes out, tool goes in. Notice the arm. Awesome. Done. And it lets you use really nice ER collets, ER20. So that's cool. This power drawbar works quite well. Depending on what you're machining and how hard you machine, you might want to upgrade the both the air cylinder to a bigger cylinder and these Belleville washers to use more of them, because it could use a little bit more pulling force. And that's one of those things you got to tweak. But I was able to machine all kinds of stuff. Hardened stainless steel, titanium, aluminum, carbon fiber, all kinds of stuff with hardly any problems with the drawbar itself. So it's not a big issue. And it's just one of those things you work with as you go along. So the power drawbar is really cool. That's obviously a custom upgrade that the mill does not come with from the factory. And it's a very valuable system to have on a mill. Okay, next up you can see the Z motor here. All three motors that I'm using are 425 ounce motors, which is pretty powerful for such a small machine. The Z motor is geared 4-to-1. There's a 4-to-1 variance between the pulleys, like big pulley here, small pulley there, on a belt drive, and the whole thing is adjustable so you can make that belt nice and tight. It actually rotates the ball nut here. The ball screw stays stationary, but the ball nut itself rotates. I have a lot of upgrades that I'm going to be including with the mill, but since we're talking about the Z area, I'm going to talk about this one right now. This is a gas strut, and it's meant for like an RV or something, but I think it's got around 40 pounds of pressure, and this spindle head weighs around 40 pounds. Now right now there's no spring load holding it up. It's just the motor itself is holding it up. So when the motor's trying to pull it upwards, it's pulling up a decent amount of force. So if you were to install this, make little brackets from basically there to here, then that'll put 40 pounds of upward pressure to compensate for the 40 pounds of weight, and then the Z motor is hardly working at all, which will make the Z rapids a lot faster. So that's an upgrade. I'm including this. I just never got around to it. There are a lot of things that I wanted to do to this mill that I never got around to because I was working or couldn't afford it or whatever, but half of those upgrades I've already bought a lot of the parts for them, which I'll be including in the sale. And then I got the Tormac a few months ago and I haven't touched this thing since, so this is just a great starter mill. You know, if you want to get into CNC or if you want to do it at a hobby level, it's a great starting point. And I turned this into a business, and I was making a good income making custom knife handles for a year before I got the Tormac. So I mean, it's definitely possible. I keep saying it's a hobby mill, which it is, but you can absolutely make a profit from it. Let's go for some more details about the mill itself. So I got that. The motor's a 3/4 horsepower motor. That's the factory motor. You can use treadmill motors, like literally from a Nordic Track treadmill or whatever. Make a bracket, attach the treadmill motor, and you get 3 horsepower or something effectively to the motor. So that's cool. This little gauge right here, it's a digital amperage gauge, and it's hooked up to the spindle motor so that when it's plugged in, like it's got blue LEDs, and it shows you how much load the spindle is pulling so that you can know how hard you're cutting and how close you are to the maximum effectiveness of the motor. Now I found out that when that reads 6 amps, that's as much power as I've got, and I need to turn down the feed rate or something and not cut so aggressively because otherwise I'll be maxing out the motor. So it's actually really neat to have this on the machine, and I'm going to be putting one on my Tormac because it's a spindle load meter. It's nice to know how close you are to the maximum. I've sort of got the stock e-stop switch and on-off switch and stuff zip tied up over here in the corner because it used to be mounted right here, but there's all kinds of cooler stuff in the way right now. So that should be more permanent eventually. But another thing I made that's really cool, see this orange, it's a big aluminum U-channel that is a spindle support. Now one thing that this mill has a big problem with from the factory is that the Z column here is quite flexible, so it'll flex forward during your cut. And basically it's just attached right here at the bottom, and that's your only point of contact. So all this weight and all this stuff is just flexing forward. And it's kind of poorly attached down here from the factory. So what this bracket does is it attaches, not only does it put a big piece of aluminum to strengthen and stiffen the column itself, but it attaches it to the back of the base here, which just gives it more of a 3 points of contact as opposed to just like 1 point. And that stiffens up the flex a lot. So you can take a more aggressive cut, you get less vibration, less harmonics, and it just works better. So that's a cool upgrade. That took me a while to make. You can see my wiring here. It's sort of just electrical tape together, but it's all there. Pretty well, decently packaged, you know, considering. I recently rewired these motors for a different style of pin configuration. They're wired for bipolar parallel right now, as opposed to unipolar. And now the way that I just did it, bipolar, is you get much more power to the motor and more power for your cut, so that's a good thing. 10 to 15 of these that I'll be including. Another thing I made is this sheet metal chip guard. So you can see the motor down there, the coupler, and when the y-axis goes all the way forward, it kind of exposes some of the stuff inside there. So this tray keeps the chips away and the coolant away, which works quite well. And in the back, it's just got the factory rubber baffle, which works okay too. I'll be including this small vise. I think it's a 3-inch vise. I use this thing all the time. Works great. These are little clampy things that I made to clamp the vise down. They also work great. I'll be including a whole bunch of these T-nuts. I made these myself just out of steel, drilled and tapped for M8 metric, and they slide inside the T-slots here and allow you to clamp stuff down. So I've got probably 10 to 15 of these that I'll be including. Another thing I wanted to talk about is the base and stand. That's just an old cabinet that I had laying around, and I made a plywood tray basically so that I could use flood coolant. Now if you'll notice, all the flat panels are angled inwards, and the mill is on a raised section right there, so all the coolant basically goes down to this drain and then goes down through this tube and into a jug, which isn't right here right now. But this jug, and it just goes through the hole in the middle, and there's a aquarium pump inside, a 900 gallon per hour aquarium pump that feeds it up through this clear hose, through a check ball valve, and up through a coolant line that attaches up to the spindle head. Attaches right to this thing, just zip ties right to there, and lets you get flood coolant, which is very nice for machining. It keeps the heat down, keeps the cutter lubricated, does all kinds of good for you. So flood coolant is definitely a win. This base that I made, I'd like to include it with the mill just because it works, it fits, it was made just for it, and I have no other use for it, so I'd like to include it with the mill. My only complaint with it, and I probably shouldn't be saying this, but I want to be honest, is that I used it for about a year, and then it started to leak in some of the seams. So I would get a drip coming down the corner here and just dripping on the ground. So if you're going to use it, and I highly suggest you do, I'd suggest maybe you just fiberglass the surface, you know, like they do on boats. Just buy some fiberglass, buy some epoxy resin, and lay a few sheets down to fiberglass and seal the entire surface down to the drain, and that'll make it like new again, and even better than before. Other than that, worked great. Now another thing I never got around to doing was, if you can see these big plywood sheets here, and then these ones are angled kind of triangles. Those are going to be walls for the machine. The big square one goes in the back. See if you can visualize this. The big square one goes in the back, and those two tapered walls go on the sides, and they taper up so it would have a glass window, basically a door that goes like that. And I've got hinges designed up that the door will go up and over. I just never got around to it. Obviously I'll be including those plywood things, and I highly suggest you make that. About 6 months ago, I was running the machine and the spindles started making funny noises. So I investigated the bearings and found out that the factory bearings were shot. So I went on to replacing them, and I upgraded to tapered roller bearings. So it's got tapered roller bearings inside right now, which are smoother and better. They require some tinkering to get the adjustment just right, but they do work very well. And just in case, I'm going to include a pair of new, basically stock style bearings. These are just caged ball bearings, as opposed to taper roller bearings. So I'm including these two in case the tapers ever fail or whatever. If you want to put these back in, I have them. So as you can see, this video is not close to being finished. I like to ramble, I like to explain things. I want you to know what you're getting into, and I want you to get excited for what the potential is here. I mean, I've been playing with this thing for 3 years and having a lot of fun with it. I mean, if you want to see it in action, I will be putting some clips throughout this video. But, I mean, I've been taking YouTube videos of me machining on this thing for years. Everything prior to May 2012, all my videos prior to May 2012 are pretty much on this machine or on my lathe. So go back in my YouTube history and check those out if you haven't seen them already. One thing I haven't mentioned yet is that the machine, unfortunately, it's not exactly plug and play. There are some components I can't include with the sale because I need to keep them in order to keep my lathe running. However, I'm more than happy to share what parts you need, where you need to get them. We're looking at like $200 worth of parts, and you'll have a rockin' setup. Yeah, if you're curious what it is, just email me. I don't want to get into too many details here, but basically you need a breakout board, a power supply, and that's pretty much it. I would recommend a smooth stepper board. Google that, 150 bucks. And you'll get faster rapids and more better stuff. But as it was, at about 50 volts, which is what I was running this machine at, I was getting about more or less 100 inches per minute X and Y, and 90 inches per minute on Z. That was before I removed the spring system on the Z head, so it's slower now, but you put that shock absorber in and you should be able to get 90 inches Z. And if you do a smooth stepper, you'll get even more. So remember how I said it's got a power drawbar system? You hit the button, the tool comes out, put the new tool in, let go of the button, you're good to go. That makes for very fast tool changes. In order to do that, you have to have the right kind of tool holder. Now these are made from 4140 HT steel, which is really cool stuff. I had a friend make these for me to my specifications, except my specifications are pretty much copying what Tormac does, which apparently you're not supposed to do. But as long as you don't sell them, and yes, I'm selling them with the mill, but it's sort of a package deal, and I don't need them anymore, so I'm selling them with the mill. So I don't know. So you can see here's mine, here's the Tormac, similar concept, and they both have a relief in here, which is important, but it's not important for me to explain that to you right now. But yeah, I have a whole ton of these now, specifically for the Tormac, so I don't need these anymore. And I need these with the specific groove in it because when I get the Tormac automatic tool changer, I need the right ones, and that'll be hopefully soon. But I'm going to be including, I don't know exactly, but probably about 15 of these. There's a couple, I mean these do work on my Tormac, but they don't work with the tool changer. So I'm going to be keeping probably just 2 or 3 of them, but I probably got like 15 for you, along with collets to go with them. Every size, like from 16th inch, lots of 1/8 inch ones, some 3/16ths, lots of 1/4 inch ones. I've also got some 3/4 inch and 1/2 inch set screw holders for bigger end mills and such. My friend did a really good job machining these. There's a 1/2 inch end mill. I mean, it actually suctions in. You can see that falling down. That's cool. Nice. Man, he did a good job. So yeah, 3/4 inch. So here are most of my tool holders, except for all the new Tormac ones that I just got. These are all the ones I'm going to be including. Pretty much all of these silver ones. Some drill chucks, super handy obviously. This one as well. I'm going to be keeping this one because it's my 2-inch face mill. I use this quite often. So I'm going to keep that one, but you get the set screw holders, you get a whole bunch of collet end mill holders, and at least 3 drill chucks. Also, if you're new to machining and don't have any end mills or anything, I've got a pile of sort of slightly chipped or used end mills here that I don't use anymore. There's some other ones here. There's some high-speed steel ones up in the corner. I just don't use these. I'd be happy to give you a bunch of them to start out with, get you started. You know, they are used, but they'll cut metal. And until you get really experienced, you don't want to use brand new fancy tools all the time. Sometimes you just want to use a beater end mill. That's why I still keep them, because I use beater end mills all the time. But when you're making anything to tolerance, you know, to be nice, you want to use good stuff. But yeah, so I got some starters for you if you want them. That's fine. And I can also, of course, recommend where you get anything you need. I mean, I've been doing this for 3 years now, and I've got a good list of places and people to get from. So if you buy this, feel free to ask me. Here's a lot of my new stuff. A lot of my Lakeshore Carbide end mills, 2L ink engraving tools, you know, blah blah blah. Lots of drill bits and stuff on the outside. These are tiny little engraving ball mills. But yeah, I've also got some old taps if you need them. These are neat. I made these one of my first projects on the mill. You can see there's a bunch of nasty chatter on the side. I've since learned how to cut a better part, but the machine makes much nicer finishes than this. Don't be deterred. This is just me being stupid. But these are really cool. They're hold-down clamps, and they've got a half-moon thingy there. Goes like that. This clamps down to the T-nut in the table, and it's an adjustable work height clamp with a nut just to create a flat spot. It rotates and stuff. These are awesome. I use these things for almost every job that I do. And I've got at least a pair of long ones and a pair of short ones to include. They're very handy. That's one of the cool things about the mill is you can make your own stuff. Like, you don't have to buy so many tools anymore because you just make it. You know, yeah, you can buy these, but you can make them too, and you can practice how to machine on stuff that doesn't really matter but can become very helpful. Probably the first year or two of your machining is going to be spent a lot of time on just making stuff for yourself. Practicing, you know, figuring the machine out. And yeah, you'll be producing parts and sellable stuff, but there's a lot of making stuff that goes on too, like tools and fixtures and holders and stuff. Speaking of fixtures, I got some cool to show you. On the machine, you'll notice there are 4 holes drilled and 2 holes that were poorly drilled on either side. But yeah, these are drilled and reamed for 1/4 inch. So you take a 1/4 inch dowel pin and it slips right into the hole quite nicely. Comes out with a little pop. And these are locating pins. And they work quite well for this machine. These are longer than the ones I would normally use, but let me show you what I use them for. Here we go. These are some of my fixture plates that I made specifically for that machine. Let's use this one for an example. This is about 4 inch by 11 inches, which is exactly the scope of the travel of this machine. You can see how there's 4 holes there and there. They align to the dowel pins. This one's longer than you would normally use, but I mean, imagine that. That makes the machine fully repeatable. You can put the fixture back on, back off. Sometimes 4 pins is too tight, so you have to use just 3 of them or even 2 of them if your holes aren't drilled perfectly accurate or whatever, but either way, you get this put on and it doesn't wiggle at all. And oftentimes for the fixture, see this little hole up in the corner, I would use my touch probe to locate on that hole every time, and that's my 0, 0 location. Everything gets measured from there. When it does all these profiles, it's referencing from right here. So that's just a cool little tidbit. But I mean, this gives you an idea of the travel scope of the machine. Here's my hand. I can fit 6 handles on here, which is great. And I made tons of these. So yeah, the cool thing with fixtures is you can make, you know, lots of different ones and swap them out. Here's a smaller one that I made. And I even made a big one. This is a set of soft jaws that didn't work at all, but it was fun to try. There's a cool little thing where I made pocket clips and a flat section. But yeah, I'm not going to include any of this. It's pretty much garbage to me now, but it's also garbage to you because you don't make the stuff that I make. So speaking of making stuff, I wanted to show you some of the cool things that I've made on this machine. I made my very first complete pocket knife that sucked, but I made all this stuff on the mill. Aluminum handles, 304 stainless steel blade. It's cool. That's my very first knife. Second knife, which is much better. These are titanium handles. Yes, I machined titanium on this thing. It works awesome. Stainless steel blade. This is RWL34. And I milled this on the mill, on the X2 here. Every part. The titanium handles, the blade, everything. I even heat treated the blade and then hard milled the blade. So yes, it can machine hardened steel. And did it fine. You know, you just keep your feed rates light and keep it smart and all that, and this knife's awesome. This is like prototype number 1 of what I now make, which are, you know, they look identical, more or less, but this one's just so much more refined and has more thought process going into it. But anyway, proof that, you know, this thing can machine titanium and gives quite a decent surface finish. I used a 1/4-inch ball mill to make these. This machine also excels at engraving. And here's kind of my tester piece. There's a little family crest I engraved. It's tiny, look at my thumb. Very cool dragon. And a Celtic cross. I mean, I made that on it. The machine works great for engraving. You put a small end mill in there, spin it to 6,000 RPM, and it works great. As long as your workpiece is flat, that's the most important thing. Let's see, what else have I engraved and made? These are my aluminum knife handles for a Spyderco knife. Made tons of these on the X2. You can see the surface finish is great. The cut is great. More titanium handles that I made. Glow-in-the-dark material. Tons of aluminum stuff. So here's my lathe. For a while I had them sharing the same control box. You can see there's a switch for my mill and there's a switch for my lathe. And because they're sharing stuff, that's why I couldn't, I can't sell it all. Okay, don't be alarmed. I kind of know what I'm doing, not really. Originally, I was using hobby CNC boards for the drivers to control the motors, and I'm not very happy with them. So as you can see, I tried to give them too much voltage to make more power, and they got really hot, so then I put on a water cooling system to try to cool it down, which worked okay, but it was a joke. Here's my power supply. It's literally out of a microwave oven, the transformer, and I rewound it to give me about 50 volts. I'd suggest you just buy a proper power supply. They're like 80 bucks. Get one that you need. Anyway, the good news is these are the drivers that I'm including with the mill. These are IM804 drivers that I got off of eBay for about $50, $60 each. And they're very nice, very powerful drivers that have the potential to give a lot of power to the motors. So they can run up to 72 volts. I suggest you go as high as you can. Run them at 60 or 70 or something. And they work really good. So I'm going to cut away as much as I can from this wiring, but you're going to have to rewire some of it yourself. But I'm happy to help with that, so please don't be afraid to ask and email and stuff. if you end up getting the mill. Don't be too afraid, it's not that difficult. More things I'll be including. If you've never heard of Haas Machine, this guy's awesome. He has a YouTube channel. I'll try to link it in the description. Otherwise, just look up Haas Machine, and also a website. And he's like the pioneer to making this mill awesome. He was my role model. I don't know. He did a lot of cool stuff that I copied him directly, and he came up with these DVDs that have plans to make all kinds of cool stuff, like an automatic tool changer. Check this thing out. 16 tool carousel that will basically take your tool holder, the carousel sits here, and the program says, oh, I need to change to a 1/4 inch end mill, and it goes, hits the power drawbar, one tool drops out, next tool goes in, it goes, that is too cool. And I'm actually really bummed that I never got around to making this. I was really looking forward to doing that. But then I got the Tormac, so I have the DVDs that include all the plans. I forget how much these cost, but they weren't exactly cheap. So they have all the plans to do that. They have plans for other upgrades. Lots of really cool stuff. He's a very smart guy. So those are included. Here is a digital touch probe that I made many years ago. I think this is one of the first things I milled on this machine when I converted it to CNC, which is really cool. What this is it's a locating probe. I can go into the hole, and it's digital. It knows when the tip of the probe moves. So I can go into the hole, hit a button, and it goes and finds exactly where the center of that hole is. Or it can do cooler things, like it can digitize and measure something. I can measure this wall, I can measure a 3D surface, I can put a toy car in here and measure every single point on it and basically recreate it, which is very cool. I'm not going to try to convince you that this is a very awesome piece of equipment, because it's the first one I made and it's not excellent, but it'll work to get you started until you're ready to buy a better one. I still use this very often when I was using the mill, so it's totally usable. Other options for that are, nope, this one, yeah. I bought one from Tormac. It's the exact same thing, just way better made. These are around $200, which is literally worth the price. Considering that like a high-end Renishaw or something is starting price at $1,000. There's another guy on eBay and many of the hobby machining forums that makes one for about $120 or so. It's not quite that nice, but it'll do the trick. So the other thing I'm including is this little touch plate. Basically the same principle as the other one, except it's used for setting your tools. So say you got your tool here, you jog it down until it touches and it tells the computer, hey, it just touched. That's 0. I'm not super happy with this. I mean, the surface has to be totally flat, and it's not. But the light comes on, and that's kind of handy. So I don't know. I don't need it anymore, so I'm going to throw it in. This is basically a homemade version of what I just bought from Tormac, which is really exciting. This is their Tormac electronic tool setter. Got a carbide face at the top here. Everything's totally flat and parallel. And it's even got an air blast tube. This thing's just cool. I can't wait to start using that, which will be in the next few days. One thing I forgot to mention is that I will include this board right here. This is called a C6 speed control board from CNC4PC.com. Great website for little knickknacks and stuff. What this does is the program tells the mill, I need you to spin at 6,000 RPM, and it'll do it. And then you change the tool and goes, okay, that's drilling. I need you to spin at 1,200 RPM. So this will change the RPM automatically, so that in your G code, you tell it what RPM you want, and that controls the spindle speed. So that's very cool. I only put that in a few months ago, and I'm really glad that I did, because especially with the power drawbar and all the tool changes, you want them all set automatically so that you're not flipping the knob, going, okay, is that 1,200 RPM? I don't know, is that 1,200 RPM? So that's cool. I almost forgot. One thing that I will not be including with the sale is my PC and monitor. You will need your own PC and monitor. Just any crappy old PC and any old monitor will do fine. Doesn't have to be anything fancy. All it has to do is run Windows XP. These are the ball screws that I'm using and the ball nuts to control the linear motion. You can see them down there. And of course the ball nut up here, you can see that. There's all these little ball bearings inside, and inevitably there's this thing called backlash. And when it spins from one direction to the other direction, it takes up a little bit of slack and causes a tiny bit of a pause. And that's always a problem that CNC machines have to deal with. So that backlash, these ones are pretty good to start out with, but so it had maybe like 4 to 5 thou of backlash, thousandths of an inch. But to eliminate that, you get these larger ball bearings, 0.1265 instead of 0.125, so they're 1.5 thou bigger. I've got some other sizes as well, and basically I've already repacked these with larger size ball bearings to eliminate the backlash. So now we're down to like around 1/1000th of an inch of backlash, which is perfectly acceptable for a small machine like this. I mean, basically, if you're just starting out at machining and you want this machine, I'm here to help you out, honestly. Just from one guy to another, I want to help you get started because I've had a lot of fun machining. I find it really exciting, really intriguing, and a nice challenge. So I want to help you get started, man, bro Namath, bro Safina. Alright guys, check this out. It was worth it because I got to play with titanium. And this is the first thing I've ever machined in titanium.